graph tracker. Nope, it wasn't. I don't know. Intuitively, it feels that I do not need a mutex for this thing. And you can see it's only being set once, which means that it is part of an initialization, which should finish before other threads start using it. Which means that there's a different synchronization required, which means that this write will be visible to other threads by the time they read it. I'm thinking about if I should add the assert theoretically also here. But it's only called, I think it's only called when so guaranteed that the graph tracker is not set here the moment you call that one. So that was extractor graph, so these two. . It is a constructor. So it has been default constructed. I added the cons here. That's not possible then. No. Nevertheless, default constructed means null. So yeah, the other one as well. No, not really. It does test it though. It just tests if it was set by this call here. But then we get back from it. Excuse me more. If it's still 0, then it was never set. So I don't know. Seems silly to add a assert there. Then we have the parent graph tracker. So this sets a parent graph tracker, but that is also part of a constructor. And I think that the parent graph tracker should always be set. Very short, well, more or less as the part of initialization. Also inside the constructor of this. Constructor, constructor, constructor. Oh, that's something else. And that is something else. Wrong question. I don't have a button that's can use to stop it. What is going on here? and of course standard weak pointer. Standard weak pointer t log threadsafe. Too lazy to check it. Now, graph tracker is thread safe. I already checked it. So then this is also thread safe. So construction happens first, of course. And then multiple threads might call this, but it does not influence the weak pointer. It's a thread safe. Actually, the same thing for this. Did I overlook that? Access is the weak pointer. So const. Is it const? Okay, now I have to look it up. Now we have to look it up. Standard weak pointer. Log. Log is const. Ridiculous, but thread safe const-ish. They stole my idea. set label. No, was just created. Yeah, well then I'm going to assume that set label does not have to be thread safe, because it kind of should be called as part of the constructor. Like it is being done here. Or immediately after constructing it. Sure. Looks like the begin itself is never changed, except this is read access. This is read access. This is read access. They're all the const member functions even, so totally need to. This is the weird thing only that if I do this, and apparently it's never changed. It remains null. Is that true? Doesn't even exist. So that means I should be able to make const, right? And then I guess int as well. Nope. Compilers generated assignment operator, I guess. Use a deleted function. Yeah, that one now no longer compiler generated. It's reset here. When being moved. Yeah, okay. So my argumentation is that if an object is being moved, then really no other thread should be accessing it. That would be ridiculous. So writing to that is completely fine. And apparently for the rest it could be const, so there is no need to add thread safety mutexes or whatever. Oh, that's just this one. Maybe we should comment it out, see how many other things like that we have. That's the only one. No, okay. region. Like literally the only one. Yeah. I don't like, even though the reset to null, because it is being moved, is okay. It's hardly yeah, correct that an assignment is being added if I don't add a mutex here. Sure, how do you say that? So then I declare memory region to be thread safe, and therefore this is thread safe. And then we have that one. Oh, what? Link. It's a different thing. Memory region 2 owner. We're still going to get the tracker or not? That is thread safe. This one was. Standard weak pointer itself is. We do not have any other members. So this thing is. And then here we have the linker, which has a map. And we have a singleton. I guess that this clause is only used here. Let's check that. So it's made thread safe here. Yep, it's only used there. I could rename it to locked. Then I know that it is thread safe. Let's do that. I have a few other clauses that I put inside unlocked. And don't begin with locked. So that's slightly confusing here on there. Let's try to find all of them. I think about it. Unlocked. So let's look for this and then substitute that followed by locked underscore with nothing. And then see if anything is left. Yeah, you cannot put locked in front of a set. Node item. Yeah, all these items. Anyway, that one. Index container sets container type. Yeah, usually I don't do that indeed for a container type. So, nah. Rank their graph data. That should have a locked in front of it, I think. It's almost like the data here. Maybe it should be locked rank their graph instead of data. There's another one called data, but that's an example. This is inside threadsafe anyway. It's just examples. I could put locked in front of it here as a suggestion. But nah, okay. So this is indeed almost, well, maybe that one, but this one definitely. Let's rename this one. Ooh, that's a lot, man. But all in 2 files. 3 files. No, that's just an include. Huh? Nah. Now that thing has its own header. I don't want to rename it anymore. I don't want to rename the files. Yeah, okay. Let's leave it like that then. So where's my using? This one. So I was working on that file. Yeah, so kind of threadsafe thing. It's wrapped in an unlocked, so this is threadsafe then by default. And that's the linker. So the whole singleton is threadsafe. Hi, Mr. David. I'm okay. I got out of bed like an hour ago, which is way too late. Almost make me depressed. I do that. I think I fell asleep at 5 a.m. Though, yeah, and then you get that. Anyway. I'll threadsafe as a singleton. So it's especially calling instance on the singleton. Singleton itself is if you call instance, then you get instance. So it's either instance or instantiate called on global. It's called go for the instantiate. Singleton instantiate. Totally not threadsafe. No, not threadsafe at all. I don't think it's threadsafe, right? Also, instantiate are definitely not in threadsafe. Maybe instances. Instance. Nobody. Jump to it. Yeah, to reach instance, which should be initialized. So that's threadsafe. So I'm calling instance here. I'm not calling instantiate on it. So that seems okay to me. Yep, no. And then the thing that it is being wrapped, that is being locked. Is it a read access type, write access type? Just go to the next node.h. That's totally thread safe. There might be more in it though. Node tracker. Well, then .node pointer is thread safe, and there's no other things. No other members. Locked node is not thread safe, but it's locked, so can only access it when it is locked. That's what it means. And then the last one is rectangle nodes, where it doesn't have any extra member variables. And well, I just looked at this one. Okay, so well, that was easy, quick. About 1 hour to finish the whole thread safeness. I was left over in this directory. Not feeling very secure about it, but it's mostly nothing. Nothing is really required, I think. Then the next thing I want to do, I think, is adding a test that does something with the with vectors. To this one is using array. I have an array here in the class D, and we are directly using arrays in main. Constructing one and then moving it, and that's it. Yep. But yeah, what works for array should also work for a vector. And I think that after that, I'm kind of done with everything except edges. I think after adding a vector, I should go back to the Vulkan engine and apply it even before I add the edges. So we can see at least something work with all of this. That eventually it has to work with. Because let's say the edges is also very difficult, and I could put I don't know how much time into it. And then maybe find out that all of it is for nothing because I can't get it to work with the Vulkan engine. It's probably a good idea to leave the edges until I get it to work without edges. That's good, David. So now you're going to take a day off. I'm just kidding. Now you're going to write a test suite for it, so it becomes easier to maintain in the future. Yawn. Now let's not add a vector in D yet, but let's add a vector here. So I need a new class, vector. I can store an A, I guess, and we need an index. I can use the same index. Call this a VA, vector of A's. Yeah. I guess I also have to pass a root graph. And then an initializer list. And I might as well use the same initializer list as here. Except of course different. VA. And this one would be VA0 and VA1, VA2. Let's give it different values. I'm going to use, well, just 3. 31, 32. Well, looks like a good start. No, let's use that just like I did with the array. So now it's almost the same thing. Pretty much the same thing, right? Yeah. And array is defined in, well, array.h. So now I need a vector.h, which might or might not look a lot like the array. So maybe I should spy on that. Vector.h. Vector.h. Okay, we have a pragma stuff. Yeah, probably need to write it. So the namespace. And then the class. I have an array, and this one also has an array memory region owner. I'm not sure I need that yet. Yeah, well, something like it, but not too much like it, maybe. Let's just begin with defining the vector. You can see you have a template here with tn and index, and that's exactly the same parameters that must be passed to utils array. And then we derive from that and I want to have my print on in the end. So here I get class vector derived from utils vector. A utils vector is defined as, I think, as an allocator even. Yeah, I am going to need an allocator. So I cannot support allocators because I need my own allocator. Yeah, well, shouldn't be too much of a problem because I never use allocators. Should I just not support the allocator? I mean, of course, the array did not have an allocator, right? I mean, arrays don't allocate memory. So this is a step downwards in terms of full support. If I remove the alloc template parameter here. Let's ignore it for now. So I'm just going to pass all of them. Index and alloc. But that must be public. And we need a header for it. Okay, and the print on, is that also correct? It prints, well, I'm casting stuff to a standard array here. Can I cast this to a standard vector? I'm not even sure it can print standard vector. Yeah, of course it can print standard vectors. This cast, of course, only works when the utils vector is derived from standard vector, and I'm pretty sure it is, yep. So actually I have to cast it to that. Or I could use base. I don't think I support printing standard vectors with an allocator, to be honest. But okay. Which clearly indicates that I need this header as well. Let's copy that one as well. Now we're getting there. Well, this doesn't do anything, of course. It just repeats a vector in namespace cppgraphviz. Now I have in this namespace a vector which is more basically the same as the utils vector. But start. Doesn't make much sense to try to compile it here though, because we're going to need a few special constructors. I guess a default constructor should or should not exist. Let's have a look at the array, how that looks like there. My arrays take root something. You must pass a root graph, or it's a copy, or it is a move. Copy constructor, move constructor, root graph, or this. That's the exact same thing as that one, except it doesn't have a root graph. I don't think I'm using this one. Yeah, this is the one that is not implemented. Should I implement it? Yeah, still pain in the ass. Try to do that. I'm going to copy this one. I'm looking at the wrong thing. Memory region owner. What the hell, man? What the hell? Array takes a root graph and an initializer list. This might be as just a default constructor or an empty initializer list. That is a copy constructor then, and a move constructor. Now let's begin with this one. No idea if it has to be a const expression. Probably not. It's a vector. So we pass a root graph. Do I need a... yeah, of course, do I need... root graph is a graph tracker. And then we have an initializer list of t. Looks correct. And a what? Yeah, the memory region owner is not possible. I think that has to go through the allocator. So we don't have this. And then we ignore the root graph for now. Okay, this is not working. Well, actually, maybe it is compiling. Vector is not a member, I'm just missing header. Vector index does not name a type. Does the other one have an array index in? It says utils array index here. Oops. We don't have a virtual print on here. Well, that seems logical, but then why does array have it? It's because it was derived from array memory region owner or something? Nope, that doesn't have it. Well, it probably does. Maybe one of these base classes then. Memory region owner. Yeah, the memory region owner has a virtual print on. But I didn't add a vector memory region owner, so mine is not virtual yet anyway. Well, that compiled. Of course it's not working, but hey, is it going to crash or is it just bad? Not working, I mean. Huh? Damn mouse. Shall we do? What is dot source run class member tests? Looks like it worked. Story grab JPEG view class member test to not visible. We do not have a vector visible here. And the reason for that is obvious. This vector is now just a utils vector, not doing anything with it. I am creating A's, but I'm not passing root graphs to the A's, so they're not being added to anything. I can also pass a root graph. So say pass G0 to the first element, then that first element should show up. Could I wonder if that works? No idea. It's not working. No, nah, I don't know. I should know that it's an A. Does my A not accept? It does. Root graph bot. Then we have that one. Oh, it doesn't. Oh, I can pass it. I can pass the root graph, but only as a second argument. The M must be the first one. Right. So I meant this G0. Yeah, and then we have an A30 here and then it's just added to the root graph because I asked it to. But the vector itself is of course nowhere to be seen. And if I'm not adding this element to anything, then it's just not visible in the graph. So now we have to extend this vector so that it is showed. The way that should work, if you compare it with the array, is that the vector must register in memory area, and then when the A's that we construct here are copied into the memory area, and that should be detected, and then we should be informed, and then we should do everything that we have to do, right? So it all begins with registering a memory area, and my plan originally was to use PMR, which I still have an example of here. It's probably very, very old. June 7th. I think it's older. Can't be just a little bit, just a month ago. Who knows? Anyway, here is an example of how we can do that. We make an allocator which is derived from std PMR memory resource. We make an instance of that allocator, and then we have to pass the allocator, a pointer to the allocator, to the constructor of the standard PMR vector. Oh boy, and I thought I was using just standard vector. So that means I cannot base my cppgraphviz vector on utils vector, because that is simply derived from standard vector. Suppose I can make it. Can make the standard vector and template parameter. Which by default is std vector. Yeah, I'm not sure if the utils vector is big. If it is big, then I shall do that. Otherwise, I might just copy it. It's not big. That's not big, right? not sure what to do. I really hate code duplication, so copy, nah. I don't know. I think for now I'm just going to copy it. And then we'll use that instead of this one to put it there. And then I need my construct. I need both of these things just back, of course. So let's copy that. Put that below here, I guess. Let's use base. Let's delete this class. That is base. Base is going to be changed and stuff. So, what do you try to use base here? I'm not sure that works. Base. Type name. Wait a minute. That's a constructor. Again, yeah, of course. Utils. Oopsie, what is the error here? I cannot do this. Oh, base. Wait a minute. I have to lose the index, I guess, at the very least. And then base already includes that anyway. Maybe I should just do this. Yay, that works. Okay, so now no longer using that. Oh, we do actually, because I'm using the utils vector index here. I'm thinking where to store the allocator. That we have to make an instance of the allocator. Can I put that inside the vector itself? Inside this object? Let's put it in the base class at least, then. Three, yes. It's useful for me because I don't have anything else to do. Just call it a hobby, but I don't do anything else. So it's more like my life. It's a way of life. I don't like reality, basically. So I'm hiding in my computer in order not to be confronted with the rest of the world. Programs are much nicer to be looking at. If you're asking how I make money, then that's private. Vector Okay, let me look again at that one. So in this case, we have array beginning with a base class called array memory region owner. I'm going to add that here as well. Oh, you're my friend, Shreyas. But then what do you mean with manage my life? I hardly manage my life, actually. Still feels pretty private. I'm willing to tell like anyone, and I have only one viewer, so I guess I could tell you, but you being the only viewer. But yeah, well, formulate your question a bit more clear, and maybe I can answer it. Vector. Yeah, I used to have 20 viewers. I mean, peak was like 200 or something like that, but it was just a quirk because YouTube was spamming everyone. YouTube itself was spamming everyone with my link. But for a while I just ramped up to over 6,000 subscribers, and then I had like 20 viewers on average, and that has slowly declined to nothing. And I don't really care. Well, less than one is not no fun. That's really no fun. I mean, I'm talking to myself, and I realize that. But I've never understood why people found it interesting to watch my stream. So if they go away, then I don't feel that as a personal. What is it? It doesn't influence my self-esteem. Put it that way. I just think it's logical. I mean, I was like, why is anyone watching anyway? But yeah, I don't know. Well, it's nice that you're here, but you don't have to be here for me. Did we talk before? Because you say you are been watching my stream for a month. Shreyas Mali. Does it ring a bell? Maybe you said one sentence before, but then I cannot remember that, of course. I'll unhide the number of viewers. Normally I have that covered, so I don't see how many viewers I have. Okay, well, you can ask me questions as well, if you want to know something. Often I'm trying to concentrate so much that I think people asking questions is annoying. Well, not annoying, but very distracting. Wow. Yeah, I wish I can go back to that and finish it, you know, because I don't like it myself. I won't say that I'm super depressed of it, but it gets in that direction. It's not really fun to realize that I'm just not making progress and maybe never finish it. It's taking way too long. It's almost, I'm almost agree. I would almost agree with anyone saying that it's not worth it. This way, too much time. But as I said before, I never give up, so that's why I continue and continue and continue. And then even if it takes 10 times as long as I thought it would, I'm still continuing, which is probably just stupid. Let's add a vector memory region owner. New class. Yeah, from doing nothing else my whole life. You have watched me for a month, so you know how I learn. I just Google it, and since ChatGPT is there, I ask ChatGPT. And I learned a lot from IRC as well. Internet Relay Chat, asking there. Like I try to do something and I try to do something, and when I really cannot figure it out, and I've tried for many hours, then at some point it's just clear that it's taking so much time to solve it on my own that it seems worth it to spend 1 hour into making a test case that reproduces and put it on one box and then ask on IRC why that doesn't work. And then some guru gives me an answer, just to fix it. And then I learn something, of course, because when I see it, I see how they did it. That's how I learned all the modern C++. So C++ 20, 17, probably even 11. I've been doing C++ very long, but most of the time before 11, right? I mean, that's just C++ 2011 is from 12 years ago. So yeah, I already did it longer than that before that. But C++ has been changed so much. It's like a completely different language. I have to say that when templates came out, so I did C++ before templates existed. And when templates came out, I started just playing with it. And I reported one bug after another. There's a lot of bug reports on the compiler with regard to templates that I created, and then they fix it. So I think I contributed pretty much to making templates work in the beginning by doing crazy stuff with it, or at least apparently stuff that nobody else had tested before they released it. These days I cannot make a compiler fail. Everything works. It's super stable now, it seems. Yeah, thank you. Yeah, I guess so, because I didn't study what is it, IT, information technology, or I've studied physics, so I didn't learn coding at all at the university. I hardly read books. You hardly ever watch other YouTubes about programming. Well, hardly ever, just never. And I've always been interested in just solving things myself. So if I come with a solution, then it's like alpha zero. It's nothing to do with the rest of humanity. So it might be quite unique. as a result of that. But how shall we solve this, man? Come on, this here. I have a new base class. The result of this base class must be that after that we have, at the very least, an allocator. So that was this allocator. You can go look at LSVI PMR example again. Clearly did not write this. This is probably clearly because it's indented 4 spaces. I would never do that. And the braces there. So this is not even my code. I think ChatGPT generated it. So this is an example that ChatGPT made. Yeah. Well, man, if you want to do something for me, spread the word about my threadsafe Git submodule. I really believe that humanity is missing out on that. Everyone should be using it. It's just too good. So maybe you can do that, make it a little bit more popular. You don't have to write books about it or convince people, but you could use it yourself. Maybe even for an assignment. So yeah, can I use third-party libraries? And your professor says yes. And then you can use it, and then the professor knows about it. It has examples. Maybe this is not enough documentation, but you have seen me use it a lot. So you have a foo, and you want foo to be thread safe. What we do here is you create a foo, but you can only access the foo when mutex is being locked. And the way you do that is by wrapping it inside an unlocked template class, and you pass some kind of policy. Yeah, you probably should look at the test suite for other examples then. This is a read-write mutex, but you can also use a primitive standard mutex. And then it just uses standard mutex. And then you create that unlocked type. That's how you create your variable. And now there is no way to access the foo, which used to be a character array, completely hidden. Now it's a protected base class of unlocked. So it's a little bit harder to use because of that. Because if now you try to use this foo as if it is a foo, then actually it seems to work, but you cannot access it. So it will say, yeah, you're trying to access a protected base class. So you should not do that. What you should do is construct an access type from this foo, and then you can use the access type to access the underlying foo. And then here are examples. For example, if you pass the foo type to a function, you can create a write access type, for example, like this. and then use that to get the write access. Or you can also first log it and then pass it to a function. So here you have a read access type, which is passed as a reference to a function. So the read log is already taken, and but you can just pass the access type object to it and then convert, use it as a read access type, but you can also convert it to a write access type. And then still access non-const member functions of the foo. And this is the most complex thing that it has. If you convert read access to write access, that then might throw an exception. So this might throw an exception. So if you call H, that might throw an exception, and then this is the way to recover. You have to recover in the function where you take the read log. So you take the read log, you call a function that might throw an exception because it can't convert it to a write log. So you catch that exception, and then you have to call read to write yield. And then you do continue, which unlocks the read log. So this object is now destroyed. So you don't have any log at all anymore on it. And then the continue goes here at the top, and you try again. So you try to take the read log again. You have to release the read log. You have two threads both take a read log, and then they both try to convert that into a write log without releasing the read log, of course. Then that logs. So one has to give in then. I mean, I have a whole test suite for it as well. So if you look on my GitHub and you look for test suite threadsafe, or threadsafe test suite, it is, then you have, well, a lot of examples. More than just that documentation there. I'm just going to copy this, I think. Do allocate, do deallocate, do is equal. Let's copy it. What the hell do we need for that? My resource. change it to my style. Okay, so now we can just add this as a member. Okay, man, just see you later. Bye bye. So now my base class of the vector has a tracking allocator, and we can use that, pass that to the constructor of my vector, which then must be a PMR vector, right? For start, all my vectors now must be a PMR vector. PMR, and I'm not sure if those use an allocator, to be honest. Let's see if we can find that back. We should probably just look at the example, but well. Do I want to look at PMR vector? It does have an allocator. What? No, this one. What? PMR is a normal vector. It is a normal vector. Oh, PMR vector is an alias template. Okay, so yeah, let's damn it. So I did not have to copy it. I could have used the utils vector. Well, I'm gonna have to go back then, I guess, of course. No. I'm keeping my tracking allocator anyway. That as well. This is my vector, which now does not take an alloc, because I don't want it to be possible to be changed. And then this is going to be utils vector. With an index and an allocator. Ding. But that is just the allocator type from this base class. So not my tracking allocator. See the... Oh, no, it's not. What? Okay, I'll fix that later. And then this becomes, well, whatever that is. No, it doesn't. This can all be deleted. Because now I'm using utils. So yeah, they use a PMR, or no, ChatGPT is using standard PMR vector here, which means that what I just did is correct, but we have to pass a pointer to it as the allocator. So I need to look at the constructors of standard vector then. Allocator always comes last, you see, but it's a reference. Very confusing. Huh? Or maybe the allocator is constructed from the pointer. That's possible. So that would be constructing a temporary allocator. Just like this. So I have an I-list here and I want to pass an allocator which can be constructed from a pointer to that allocator. That should work. So not a base, whatever. Now I should be able to use base here again, I think. And there. Yep, that works. Okay, so now we have this test here, or not. We have this test here. Ignore everything else, that already works. I just put this line here, which creates our new vector in the namespace cppgraphviz. This new vector now uses this class that is derived from utils vector, which uses polymorphic allocator, which means that it can be constructed from something that is derived from polymorphic memory resource, which we allocate in the base class here, the base class of vector, and I'm passing a pointer to that allocator then here, and that creates a temporary allocator, I guess, which somehow survives, which means that we will be using this memory resource, and therefore we expect it to print, to allocate and to deallocate. Ja, got it already compiled. Let's run this. And now I have to find back notice do. Yeah, maybe I should comment out everything else because that's a bit much. Let's go to the top. Ish. It's one of the first things, isn't it? Do allocate. No, there it is. So yes, we are using it. So directly after constructing all the three elements of the vector, namely this one. It's the first element is constructed, second element is constructed, the third element is constructed, and then the polymorphic vector is constructed, which causes us to print do allocate. And I guess at the end it's also going to destroy it, so that's do deallocate, I think. Yep, also called. And then we have maybe something else. So the other one was do compare, I think. Nope, it's not called. Okay, just those two. Oh, that works like a charm. Then I have to make a register a memory region. So what the hell is the memory that we have here? To allocate, return, allocate bytes alignment. What is this returning? Let's look it up. New delete, what? New delete resource, yeah, indeed. It returns a pointer to a memory resource. There's a pointer to a memory resource that uses the global operator new and operator delete to allocate memory. Oh. Is that a pointer to itself? Cannot be. Okay, allocate bytes alignment. I need a resulting pointer. Yeah, bytes alignment. Returns a void pointer. That's what I need. Or do the deallocate, we get a pointer. That's at least something. Confused. Oh wait, I'm not confused. This calling allocate, yeah. So it's returning the void pointer. Hello, I'm so stupid. So void pointer. Let's call it pointer. Is that return pointer, and the size is simply bytes. Or not. Yeah, definitely. Of course, what is returned could be larger than bytes, but bytes is the required size. The alignment I don't care about. It will be aligned with alignment, this pointer. But it's just the memory area that we're talking about is start set pointer and is bytes long. Yep. So this point here I need to register a new memory region. Much like in the case of array. So let's look at my array again, because that's doing it already. If we create an array, the array also registers a memory region by passing to its array memory region base class the root graph and the start of the array and the size of the array. It also passes a type ID index, the type ID of the index. And the get index label index. I guess we have to do all of that as well. So let's just copy it. I'm going to copy it completely. I don't know. I'm guessing that well. Just need everything, right? And then a little bit different. So the whole base class constructor. Okay, so this base here, that was the utils vector. That is the utils vector. It's base number 2. It must be constructed after the first base class, which is then the first base class. And we want to, that's actually called the vector memory region owner. We pass the root graph, which we have. And we can't pass this because we don't have it. That would be the beginning of the allocated memory, and this is the size. Well, we don't have that either, but we can pass the type ID of index, and we can pass the index label of index, whatever that is. And what's with the what? Yeah, we do have a what as well. And I need a comma and then the second base class. Fits on that line. So now we can make yeah, keep it protected. I'm gonna make it public. It's kind of, I don't know. Why would I make it protected? So like that, and then we have the root graph. That's this one. And the type ID. Okay, so I'm going to go back to the array. That would be this one. Type info. This one actually, these two. Now I'm confused that I see that I also have one that does not get a demangled index type. Is that needed as well? Oh no, that's because this is a copy constructor. Copy and move constructor. We are talking really about this one. Also here, those two are just paused. This one doesn't have the root graph, so it's more like that one, and then minus the actual memory block. But we do need to pause those. I have to do something with that. Probably have to pass it to that one, because that's the one that's going to have to register everything. This clause is just used once, just a base clause. I'm gonna assume that we have to just pass everything to that object. Graph index type info, demangled type name, and what. But we're not sure, so let's look back. At the array. This is what the array is doing with it. Prints out that it's being called. It has a table node pointer. Yeah. Let's ignore that for now. Well, I have no idea what's going on here. Yes, I wrote it. Okay, it's nothing to do with the memory region. The memory region that we were starting with is just a base class. There it is, memory region owner. Well, this is the memory region owner. Yep, and that already registers something. Yep. So this is the memory region, begin and size. We create a memory region owner, all that, which remembers the memory region and registers it. The reason it remembers it is probably just so it can deregister it. Unregister, yeah. And then in the destructor, it also unregisters it if it still exists. That's the only reason this remembers it. We don't have to do that, I think. The vector is just destructing the memory, and everything can go through the do deallocate of the memory resource of the allocator. But we do need these two lines. Now this is a singleton, so I can just get access to it, lock it, register the memory region. Then there's a tracker here. What is that tracker then? That is a member of the memory region owner. Memory region owner is a tracked object, so the tracker comes from the tracked object. That's slightly problematic because that kind of seems to indicate that we have a one-on-one relationship between a memory region and the owner. Well, that is well, now I think about it, that is also true for a vector. A vector is just one big continuous allocation. So there is a one-on-one relationship. There could be temporarily two memory regions. If the vector is being moved, I think it's going to allocate a new memory block first and then copy over the smaller one. But it's not really our concern. I think that if we just forget about the old one, at the moment we are, let's say the do allocate is being called because the vector is being resized. And then I register, I can just register it. No, I cannot, because if a registering would mean, oh, this is confusing. Yeah, I can, let's say I can replace this variable here. This is just replaced with a new larger allocation. And then after it copies the data, moves the data of the vector, and then deallocates the old memory of the vector. Then calls do deallocate, which then unregisters just simply what is passed to the do deallocate, because it passes a pointer to that. Cool. I don't need that variable for that. Yeah, so I think the bottom line is that because we don't need this memory region variable, really, we can just make the memory region owner be the object on which I want the on memory region usage to be called, which would be the vector, I guess. What was it called? Usage. So in the case of the array, it's actually called on the array memory region owner, which is a base class of the array. So we get what that does is it gets a pointer to the beginning of the memory region and a pointer to the item that was just copied into it, and then it calculates the offset from inside the memory region, and therefore it can calculate the index in which the index of the element that was just copied into the array, which of course must be within the size of the array. And it updates the table node pointer, but I'm going to do that afterwards. Yeah. Convert the item to a node. Convert a node to a weak node tracker. And then store that. That has to do with stuff that I'm not doing yet. And then we update the root graph tracker on the item, because you didn't set that. Yeah. The only real thing that we need here is element size in order to calculate the index. Yeah, begin also. Could be easier to do this inside a vector than inside the memory region owner base class. So I have to store these things again there. And then of course a table node pointer here. Ooh, and the ID to node map is also something that we need, apparently. See where those things are stored. Table node pointer. Yep. All of that stuff. Except number of elements. That varies. In the case of a vector. And then these two. Now I could store the element size in here, but we cannot store the number of elements. That changes, and we cannot even store the begin. That's really a function of the well, the current vector, just which could be moved in memory. So on the other hand, we get a new allocation, so then we could update begin. But why not just do all of this inside the vector? I don't know why it's put here. The same argumentation holds for the array, I'm afraid. I could remove those three. I can just remove them if I move this to the base class, so to the derived class, which would be this class. So just not have that and just put everything here. Seems easier. I'm kind of scared to make that change now, even for the vector. So I'm inclined to copy this for now and then make it work and then maybe change it, if you get what I mean, for the vector. Already have a virtual table, so I might as well add the virtual functions for these three things then, for the case of the vector. Yep, array memory region owner. Let's derived from these things. Okay, so this seems like going slow, but hey, we did make a decision to have a one-on-one relationship between the memory region owner and the vector. Vector is derived from the vector memory region owner, which is derived from the memory region owner. And I don't think that was a too trivial decision. And then we probably want to oh, still difficult. Probably have to copy stuff here. I'd rather first write a code that needs it, which is this. It's kind of silly. Don't need that one here. Oops, I should not have done that. Where am I now? Array.h. Next, F8. Like that. So these two can be put in CXX file and this one I'll just keep here. So yeah. Not passing anything yet. Just this pointer for the owner. And then I want to call, if the do allocate is being called, I want to call here something like void bleh. Region owner. In the end I want to call that. But we don't know the tracker, we know the memory region, I guess. Or maybe it's just register memory region. And unregistered memory region. I could give them the same name. No, memory region is like 8 bytes. No, wait, 16 bytes. Oh, still pass it by value, I think. Memory region. Unregistered memory region. Also, the unregistered memory region takes a memory region or just a skin point to it? Yeah, the whole memory region. Okay. And then I want these things to be called with the correct memory region from those virtual functions. Where the memory region is constructed from begin and size, right? Begin and size, yep. No, I'll call that one P, I'll call this one P. So now these two are called, which then, well, should do exactly what they say. Let me just also copy them. Well, I mean, implement them in the .cxx file. Will you believe that I forgot what they came from? So vector memory region. Oh no, I think. Yes. Oops. Okay, and then you can go back to the array, I think, which is doing some registration in. Or not. No, it was memory region owner is doing that. Oh, so you can go here. It's kind of strange. It's doing it in the constructor, so that's like a horrible one-on-one relationship. Yeah, I'll just use the default constructor and never touch it. So let's not use it at all. And then we just steal the code from the constructor for the registration. Item. Oh, it's defined here. In MemoryRegionOwner.cxx, which is not where I am. Using this as type name feels more intuitive, better fits the pattern I'm used to. And here, because it can't be defined in the header of MemoryRegionOwner. Okay, I'll just copy that. And then you have to do that here as well. So I need the header of this thing, which is that header. And of course, I think just vector.h sys.h. Yeah. So this works for me, except we don't have the tracker yet. But the memory region now we have. We can register it. And I need to duplicate the code to unregister it. How does that work? Well, I just copy that, I guess. And then we call unregister memory region, that should work. Is that printing debug output? It is. Entering. So now we get to see that it is actually being allocated, registered and unregistered, I hope. But I still don't have my tracker. It's a weak pointer to a memory region owner tracker. Mommy. Oh, we have that. Just at the base class. It's hidden here. So tracked object is a memory region owner tracker. It's a template parameter of tracked object. So that is track type, and then here we have tracker, which is a shared pointer to that thing. To the second template parameter. Now you think about it. What? How does this compile then? Where did I get this from? Oh, yeah, sorry, utils tracked object. This is threadsafe, so I have to go to utils tracked object as a tracker C template parameter, and then that's what it's pointing to. So this tracker is what we use, which just points to the tracker, which is the memory region object tracker thing, whatever, it works. As long as we are inside this thing, memory region owner has the tracker. That's this one, therefore we have a tracker, just somewhere in the base class of the thing. Good, so should compile, I guess. Of course it doesn't. Error no matching function for call to label nodes. Candidates takes a what? Can expect to. Well, let's just go there and see which we want. Oh, there's a lot of them. Yes, a lot of them. Now we want this one or that one. You have to pass a what and maybe a root graph. I'm just going to spy on array again, I think. It's also derived from label node, that's where I got it from. And the label node gets passed. Nothing. That's because the constructors are not defined here. There it is, a root graph and a what. If we have a root graph, let's just pass it, otherwise don't. It's a gist of it after memory region owner, which I'm not using, I think, in this case. Label node, yes, you have a root graph, and we have a what. Cannot declare variable VA to be an of abstract type GraphViz vector, because the following virtual functions are pure within virtual void all memory region usage. Oh, forgot to implement that one. I have to add that to vector, right? Yeah. Vector. Is it really vector? On memory, this is probably this one. Yeah, of course it is. Let's again compare with array. That is on memory region usage. Sorry. So yeah, on memory region usage. It's defined in the base class memory region owner. No, not doing anything, but we print it. Void. What is it? Tracking allocator on memory region usage. Marked override does not override. Oh. On memory region usage. I added it to the wrong class. Yeah, very good. Hopefully I did this one correct. Yeah. Undefined reference. Yay, it compiled. Undefined reference to vtail or CVB graph tracking allocator. Okay, we'll go all back to compile errors, of course. Didn't even try to compile that one yet. has not been declared. Well, maybe I should include utils as print on.h. Expected class name. Does it know what memory region owner is, I guess? That is defined in MemoryRegionOwner.h. Bet it doesn't even know what the label node is, so now I have to include that as well. Label node.h. So anything else? Well, just let the compiler decide. Yeah, there are no arguments to get index label that depend on a template parameter, so a declaration of get index must be available. In other words, missing header. Get index label is defined in get index label.h. You could have guessed it. Include index label.h. No mention function for call to register new memory region. Yeah, I have to pass memory region. Invalid conversion from void pointer to character pointer. Oh, wait, I saw another mistake. This is still PTR. Oh, what the heck, I'm going to go back to pointer. I never use P. Invalid conversion from void pointer again. Huh? Oh, that's returning a void pointer. Oh, oops, yeah. The function is returning a void pointer. And here you need a character pointer. Okay, I think you can do static cast. Character pointer. No matching function will call to unregister memory region. Same mistake. This is also bullshit then? No, it's not. Okay. Valid conversion from void pointer to character pointer. Again, I could have known that one. But I was stupid. Okay. Well, tracker is ambiguous. Always annoying. Now why do we have two trackers? Oh shit. And that's not the case for the array. It's in vector memory region owner, and then still ambiguous. Gotta be kidding me. It's probably label node has one as well then. So we have memory region owner as a tracker. It's a tracked object. Yep. And then label node is also a tracked object, you're going to tell me. Label node is a node, which is an unlocked tracked object. Which is unlocked. Unlocked tracked object. Sounds like it is a tracked object. This tracker. That's what I expect here. Oh, well, I'm an idiot. That's in the base class of unlocked. So in this one, first argument, first template argument, in lock node. Lock node is indeed having a tracker, which comes from that base class. Man, I have so many base classes here. It's absolutely unbelievable. As a tracked object. So we have two base classes, both of which are tracked. That's not allowed. Ouch. And how came that to be? Label node is tracked. Why is my memory region owner tracked? It's totally tracked. So the array must have the same problem then. I'm pretty sure that so here we have a tracker. No, really? I would have copied that. So where did I copy my tracker from then? Did I copy it? Oh, I copied it from the memory region owner itself directly. We stole the code from that. Okay, okay. Wait a minute. Yeah, this code is stolen from the memory region owner. So, but now we are not in that class, so we have to specifically say which tracker we want. And now it compiles and links. How beautiful is that? So let's look at the debug output. No. Unknown label node has appeared. I didn't set a label node. I didn't set a label. Yeah, that's true. But I'm mostly interested now in my debug output, which is way too big. I'm gonna simplify this test, I think. Restrict it to just the vector. Let's not do an array. No array. And just a vector. Really? Nah. Undo. No, let's leave it there. And if I need to do that too. It's still a lot of debug output. Jesus. Constructing G0. Maybe I should add a debug output for constructing the. Oh, I can see that here. Yeah. Okay. What was this one? Do allocate. Look node. No, I want to see debug output for when we start to construct a VA. Well, that doesn't help. That is not helping. Oh, let's do it anyway. But it's not helping. So here we're constructing VA. Now, first thing that it's going to do is construct all the elements in the initializer list, or what's the thing called? It's not an initializer list. Initialization list. Being VA0. Calling the constructor. What the hell is that? The thing is, by the time this is called, we are in the body of the constructor of A. And I think that the rest of the debug output is simply the base classes of A. So the base class, one of the base classes is unlocked, which is constructed. This is a tracked output. Unlocked is tracked, so it prints whenever unlocked is being created and destructed. So the track number 5, all kinds of triggers. But this is a construction, destruction, copy and move tracker for objects. Maybe you should turn the whole tracker off, because I'm no longer really interested in tracking the unlocked itself. Let's see how that looks like, if that's a better readable. Before I remove it from the code even, I can just turn off the tracker debug output. The tracked debug output, rather. It's still on. Why is it still on? Tracked. Oh, it turns itself on. Don't turn yourself on, thank you very much. Now I have to compile it again. Yep, now we only have notice as debug output. Constructing G0, constructing the VA. Okay. There is an inform owner of. That's quite quick, because we didn't even allocate anything yet. So what is it informing? Who did allocate what? Huh? Here again. Oh, maybe nothing. It just constructing it. It's constructing it here. And then it's informing the owner of, which does not exist. There is no owner for that. So we construct a locked node, which is base class of A for the first one. And then for the second one, or the last one. And then I would also expect indeed that the inform owner of is yeah, okay. Just before it prints that, probably part of the base class is doing that already, before the thing is even initialized. So this belongs to something else. And again, nobody knows what. Let's ignore it. Okay, so my vector is called VA and has its own node. That means it's going to appear in my graph with the title VA. And that should be the vector, the whole vector then. It's being added to G0. And then it's finally allocating memory for the vector itself, which is registered. So we didn't even register anything before this. And then afterwards we have this memory registered. And now we get entering inform owner of, which is found. And therefore we call another inform owner of, which is not found. And therefore we use the first one and then call that function, which is vector memory region owner on memory region usage. This is then probably the first element. And it's a copy of VA0. And we don't do anything with it. I guess we don't do anything with it. So the last thing that is being printed is that one. That was an empty function. Okay, and then the second argument, inform owner of, not found, entering on memory. This is the second element, that would be that one. And then we have that one more time for the last element, yay 2. And then we are completely done. Next we destroy everything. And then we call right dot. And then we deallocate, which causes an unregistered memory region, which is indeed erased, and then afterwards we do not have anything registered anymore. So this seems to work, except that we don't do anything yet. Yeah, I probably should go do something else, like eat dinner, cook dinner. Maybe it's a nice point to stop for the moment anyway. This kind of works, this part. What would be next? I think we have the whole detection part done now. So next is just implementation of this. I have the feeling that something is missing though. If you look at the array, it does more than just implement that function. Array is not doing much. Just doing its array construction thing. It's really all in the array memory region owner, which is all this information. And let's have a look at the constructors. See, the constructors are doing quite a lot already with a table node that I don't even have in my vector yet, I think. This is doing quite a lot. Copy elements, seriously? It's pre-creating the node pointers. Oh, right, yeah. Yeah, it's making the index table because the size is known. So we make a table that is just has the size of the number of elements in the array. And then if anything is copied into it, then the only thing that we have to do is update the existing table. So it's really doing a lot of stuff with the table node. And then when we get the actual on-memory usage, it just finds the index and then updates the table. It's kind of like that what replace element here. As well as something else that I don't understand. This one. What the hell that is being used for. Maybe I can just ignore everything and just do this last line already, and then we see at least all the elements pop up in the root graph. Or not. Set root graph tracker. Yeah, then we have a root graph. No, yeah, well, yeah, maybe. I mean, I'm not setting a parent graph here, so, but if we return from this on memory region usage and then we don't have a parent graph, it's probably going to make make the parent graph equal to the root graph, aka add us to the root graph. Where do we get the root graph tracker from then? Oh, it's just stored. It's an element of. I can do that much. Where does this root graph come from? I'm gonna do this much and then I'm gonna stop for a while. Maybe even go shopping. What is this? Graph. And one more file to edit. Next. F8. Paste. So let's do this, and then nobody knows what the item is, nor do we know what the root graph tracker is. I have to steal that. We have to steal that. Vector.cxx. Let me just write everything. Is it not like better to do this? Yep, on memory region usage. Okay, so item comes from item reinterpret cost 2yy. Next, paste. So we have a memory region, that is the memory region that we copied into. I think it's the memory region of the element, right? Item, yeah, it literally says so. Item memory region. So we can get an item pointer then from that, and then we have the item pointer. Yay! Okay. Now I still need a root graph tracker. Where does that come from? The root graph tracker is an element of this object apparently, but I don't think it is literally stored here as an element. It's not. Must be part of one of these, probably level nodes, but I'm not 100% sure. Let me check this one quickly. No, that is not. That has no idea about root graph, so it's a label node. No, you already have a label node, so it probably just should compile then, right? Root graph tracker is accessible as a member of the label node. Yep, base class. But does it work? That is the question. Nope, it doesn't. Now let's set a breakpoint here and quickly look at what happens. Class memos test. So we do not have a root graph pointer. Root graph tracker is 0, and the parent graph tracker is also 0. It's the only arguments we have here. Probably have to do a cast to the node to see what it is. See what it really is. Or I can just go up. Item memory region. That comes from the region comes from item memory region here. Let's pass as the second argument. Probably still objects. That's also the item, just item. And the object comes from being passed as a second argument to the constructor of item. So again, this object then. Still an item. That's being passed to item template as the last argument. Second one. That's this pointer. So it's a locked node. Why so little information here? Yeah, it's a copy of the other log node. For that one. It's an A. I thought I would get to see the what. Let's see what was copying here. Log file, it's a copy of unlocked original. Now we have a what. So it's just the first element of the vector that is being copied here. Not 0. So now the root graph tracker is being set, has been set, and I want the parent graph tracker to be set as well now. So we go back. Oh, yeah, it's not doing anything. What? Inform owner. Okay, well, not I don't know what it should do. Slightly worried to say that this call should have set the parent graph tracker, since it doesn't have one, but I'm not sure. Or maybe, yeah, no, I don't know. That at the very least you could say if it should set that and it doesn't, then maybe we should set it here. And I think certain code is doing that. So this declaration, this is the actual call. This is just a declaration, comment, declaration, and debug output, declaration, debug output. This is just one call here. So it must be confused with something else. And I left the debug already. Very smart. Damn it. So maybe it's the inform owner of. I should have stepped a little bit further. Form owner of, also not. It's the only one point that calls that. Immediate return. Inform owner I meant, so it is inform owner of then maybe that is doing that. Well, the call point that is. Wait, this is inform owner of. Huh? Inform owner, yeah, oops, okay, so inform owner of, you see this sets parent graph tracker, that's what we expected to do. Declaration, debug output, there's an actual call here. And another one. And two other ones, lots of calls, I should have stayed in debugger, try it again. Debugger, and then we want to stop where break there. Already did that, so I'm gonna do frame 0. What? List. Okay, next. So now the root graph is set. The root graph tracker. And then we do step. Step. Form owner of. What? Constructor of item. Ah, that's what I meant. Parent graph tracker is set to the bloody root graph tracker. Oops, or not. Right, so there's a bug here. 63, 64, good enough. The root graph tracker here is set to left the debugger again too soon. The root graph tracker could be passed to be null. And then we call this function, and that sets the root graph tracker on object. But object is not necessarily, yeah, object is this object. I think this is called set here. So there should have been an underscore, because it can be set by that call. Glorious. Much better place to stop here. Hey, I was just going to stop. Serious. My, I'll show, but you can just see here. Oh, beautiful, isn't it? You have all three added to the root graph now. As a result of detecting that they are being copied into memory area that was allocated as part of a vector, they appear here. So definitely did something, right? Now I'm thinking, was it a bug? Was it a bug? Because I don't really want this to happen. I don't want it to be added there. Really. Well, it's nice that it works after I made that change, but yeah, I'm strongly doubting that this is correct actually. Object does not fall into a register memory region, then it has to be added to the root graph. Okay, if it does not fall into a register memory region, then the root graph will also not have been set. So then this is correct. If it does fall into a register memory region, then the comment says that we don't want to do this. In other words, it strongly suggests that my inform owner of must set the parent graph tracker. And we didn't yet. So yeah, the parent graph tracker should be set to the table node. And we don't have the table node yet. So it doesn't really matter. I can use an underscore or no underscore here, because we should never get here. And if we do get here, then the root graph tracker underscore will not have been changed and therefore still be equal. Let's just leave it like it was. Then the array was having a table node pointer. There we have the table node pointer. And that is definitely an important thing that I need to implement. And there's a one-on-one relationship with the vector, just like with the array. But I don't know the size of the table. That is quite annoying. Hopefully not onoverkomelijk, whatever that is in English. Not a big problem. Yeah, I'm going to cook, so we'll end the stream and then I'll be back later. Shreya says, I need your help. Actually, I have an idea. I need to implement, but I don't have required. What? I don't have required. No. Is there a way where I can text you? You can, but I am extremely slow in reacting. Which is not really a problem, because if you work on something and I mean, you only learn when you do it yourself, right? So if there's a few hours delay between you asking a question and me answering it, then fill those few hours with working hard on your problem. That's yeah. I have a Discord though, so you can join that and then ask there in public. Never ask me anything in private, please. It's not. I don't like that. Trying to clean my keyboard. Okay, I have to go to Discord. And then we go to my server, and then I go to invite people, and then we copy the invite. Yeah. And then you can ask your question in general. Ask question in general, I guess. Well, 20 people online on Discord, and I have 2 viewers. What? Yeah. I'm going to cook. Wait, Post Bunny says something. Oh, that was from yesterday. Yeah, that's what I mean. And then there's another friend who said something. Hi. Day 5. Hey, I said hi back. Hi. Going to make dinner now. That's a good thing. Did get out of bed at 3 p.m. though. What is that? Template literal? Ask on